Hello, dear students. So, today we will start the third chapter of your maths class 12 NCERT portion. So, the third chapter is your matrices. Till now, we have uh, learned about two chapters in your maths class 12. That are your first chapter was relations and functions, and second was inverse trigonometric functions. I hope that you liked the previous sessions. If you haven't seen the previous sessions, you can go and watch on the GoAskNow Academy channel. So let's start the third chapter, which name is matrices. So this is new for you, but I will explain you. So the knowledge of matrices is necessary in various branches of mathematics because matrices is like arrangement of any things or any like material. So it will be helpful for you. Matrices are one of the most powerful tools in mathematics. So, for like systematic approach of mathematics, like arrangement, reordering, or like these things, matrices is very important. So, this mathematical tool simplifies our work to a great extent when compared with other straightforward methods. The evolution of concept of matrices is the result of an attempt to obtain compact and simple methods of solving system of linear equations. So if you have like linear equations and these are like very much in numbers, like you have solved earlier that linear equation in two variable or three variables. But if you have linear equations in more than three variable or four variable, you can easily solve them by using the matrices method. Okay. And matrices are not only used as a representation of the coefficients in system of linear equations, but utility of matrices are like far exceeds that use. Okay. So matrix notation and operations are used in electronic spreadsheet program for personal computer, which in turn is used in different areas of business size like budgeting, sales projection, cost estimation, analysis, analyzing the results of an experiment, etc. So there are multiple like applications part of matrices that is in real world scenario also. So you must have this knowledge of matrices. Also, many physical operations such as magnification, rotation, and reflection through a plane can be expressed mathematically by matrices. Okay, matrices are also used in cryptography, and this mathematical tool is not only used in certain branches of science but also in genetics, economics, sociology, modern physics, like psychology, and industrial management. So yes, these are like many applications of matrices. So you must be like knowing these things. So in this chapter, we will learn a matrix and matrix algebra in detail. So what is matrix actually? Suppose we wish to express the information that Radha has 15 notebooks. It means that there are 15 notebooks that belong to Radha, and we may express it as 15 in brackets. Okay, with the understanding that the number inside bracket is the number of notebook that Radha has. So this is one method of representation of like books owned by Radha. Okay, bracket representation or array representation. Now, if we have to express that Radha has 15 notebooks and 6 pens, we may express it as what? Like array of two objects, that is 15 and 6 in brackets, with the understanding that first number inside the like big brackets is the number of notebooks, while the other one is the what? Number of pens possessed by the Radha. Let us now suppose that we wish to explain the information of possession of notebooks and pens by Radha and her two friends, Fauziya and Simran, which is as follows. So if we have like more than two people or one people, then we can also express in it in a like array of or arrangement of some numbers or objects. Like Radha has 15 notebooks and 6 pens. So Fauziya has 10 notebooks and 2 pens, and Cyprian has 13 notebooks and 5 pens. So this can be arranged in tabular form, or that is called your array form. So Radha and then notebooks and then pen. So this is your names. Like first is for Radha, the notebooks and pens. For Fauziya, that notebooks and pens will be written there. And for Simran also, the notebooks and pens will be written in the next array. Okay. This can be expressed as like big bracket 15, 10, 13, and 6 to 5. So 15 and 6 are in the first row. See carefully that 15 and 6 are your in first row. Okay. So this is your called your first row here. This one is called your first row. That is the horizontal one. Okay. Horizontal arrangement is called first row. And the 10 and 2 is the second row. So you must see here that the horizontal arrangement is called what? Row only. And this is your third row, 13 and 5. But if you see the vertical arrangement of your numbers, then it is called column. Here also you have second column. So how many columns are there? 1 and 2. And how many rows? 1, 2, and 3. Okay. So I hope that you got this point, that what is the actually meaning of your row and column. So this must be very important for you to know these things, like what is the row and what is column actually. Let's move further and see what is the next thing. Let's move further and see. Yeah. So here, this is your. This was your first arrangement, and the other can be arranged in other way also. Like if you have notebooks arranged in a horizontal manner and pens also in a horizontal manner. Okay. So then it will become like a two rows arrangement and three columns arrangement. So this is another way of representing these arrangements or array. So here it becomes first row, then it becomes second row. Okay. And this becomes first column, second column, and third column. Okay. So two methods are there. If you can arrange it in horizontal manner also or in vertical manner also. Okay. So let's move further and see the next thing. In the first element, the entries in the first column represent the number of notebook purchased by Radha, Fazia, and Simran, respectively, and the entries in the second column represent the number of pens purchased by Radha, Fazia, and Simran. So that was the thing that in the first column the books were represented, and the second column your pens were represented. Okay. In the second arrangement, what was the difference? The entries in the first row represent the number of notebooks purchased by Radha, Fauzi, and Simran respectively. That was the first row was representing the notebook purchased by Radha, Fauzi, and Simran respectively, and the entries in the second row represent the number of pens purchased by Radha, Fauzi, and Simran. Okay, so here the row and column difference is there. Row and column difference is there, and a arrangement of display of the above coin is called a matrix. So this is your important thing, that what is that? An arrangement or display of the this kind is called a matrix. Formally, we define matrix. So this is the definition of your matrix. What is that? A matrix is an ordered rectangular array of number of functions. Okay. The matrix is what? It is an ordered rectangular array of numbers or any functions. The numbers or functions are called the elements or the entries of the matrix. So these are called what? These numbers like this. The single entry is called your entries or elements. And this is collection of your rectangular array of numbers or functions. We denote matrices by capital letters. The following are some examples of matrices. So if you say that this is a matrix, we denote it by a capital letter, or like this, or this. Okay. So these are the representation of a matrix by capital letter. Yes. So let's move forward. In the above example, the horizontal lines of elements are said to constitute rows. So this I already told you that the your horizontal lines are or arrangement are called rows, and the vertical lines of elements are said to be constitute column of the matrix. Okay. So here, see in this example, like in the above, you can see that the A matrix has your two columns, because there are two vertical lines or arrangements. So two columns, one, two, and rows are how many? How many rows? 1, 2, 3 are there. Similarly, for B, it is like 1, 2, 3 rows, 3 columns, and 1, 2, 3 rows are there. For C, here 1, 2, 3 columns are there, and 1, 2 rows are there. Okay. So I hope that you got this point, that what are the rows and columns actually. The next thing is, what is the order of a matrix? So, like you have studied earlier, that what is the order of differential equation, or like that on this. So it is the other way of like is knowing the matrix identity. This is called as order of a matrix. Okay. So a matrix having m rows and n columns is called a matrix of order m cross n, or simply m cross n matrix, read as an m by n matrix. So if a matrix has like m rows and n columns, so you can like represent it by order m cross n, where m is what? Your rows. So first thing, that first number is what? It is your number of rows only. M is representing number of rows, and n is representing what? Just a second. Yes. So here your like uh, order of m cross n, or simply m cross n matrix, read as m by n. So m by n is what your order, where m is number of rows and n is what? Number of columns. This you must remember. Okay. So referring to above examples of matrices, we have A. So here A matrix is what? Here, what are the number of rows here? 1, 2, 3. So 3 cross 2. First two columns are there. So 3 cross 2 is the order of A. Similarly, for B, tell me the order. You can say that the order is 3 cross 3, because 3 rows and 3 columns are there. For C, it is what? 2 cross 3. These are the order of the matrices here. Okay. We can also observe here that if you see that A has 3 into 2, that is 6 elements. So whatever is the order of your matrix, the product of that order is called what? Or is the number of elements inside the matrix. Okay. The order is very important. The product of order is called what? Or is the number of elements. It gives you number of elements. Okay. So let's move further and clear the drawings here. Yes. So in general, M cross N matrix has the following rectangular array. Okay. So you can see here that if you have like M cross N matrix is there, so you have like M elements in your row, or M is the like number of rows and N is the number of columns here. So what are the like element of these numbers? If you have like, this is your what? This is your first row, first column. Okay. So this element is A11. This is your first row, second column. So this element is A12. Similarly, for third row and like first row and third column, it is A13. Similarly, for like nth your column and like first row, so A1n. Okay. Similarly, for second row, you have A21, A22, A23, so on, A2n. Okay. Where n is what? N is your number of column, and 2 is your number of row. Really, you will like go on like this for the mth row. Your mth row, the first element is what? AM1, then AM2, then AM3, and it goes on like AMN. Okay. So the last entry will be AMN, because MN like is the order of M cross N is the order of your matrix. So M cross N should be the last element. Okay. So here you can see that A is Aij, where m cross n is the order of this. So it is the way of representing your matrix Aij m cross n. Okay, where your I is greater than equal to 1 and less than equal to m, and j is greater than equal to 1, like j is greater than equal to 1 and less than equal to n. And ij belongs to what? Natural number only. So this is a way of representing like element of matrix or your representation of matrix only, because A is represented as like this only, Aij m cross n, where I belongs to m to n. So these belong to natural number, like I is the number of rows only. So you can see that I goes from 1 to m because m rows are there, and j goes from 1 to n because columns are there. So that is the way of representing the elements. Okay. First, the ith row consists of the elements a1, like ai1, ai2. Like this is the representation of your any row of elements. So ai1, ai2, ai3 up to ai n is the representation of your like nth row element. Okay, or ith row. Sorry, ith row element. And while the jth column consists of the elements like ai, a1j, a2j, a3j, like up to go on to AMJ. So this is the way of representing your jth column. I hope you got this point, that how to represent the elements of any row or any column. Okay. In general, Aij is an element lying in the ith row and jth column. So like Aij will represent what? That it has ith row and jth column as the position. Its position is ith row and jth column. We can also call it as the I comma jth element of A. So this is also called as I comma jth element. The number of elements in an m cross n m like matrix will be equal to mn. But this I already told you that the number of elements will be equal to product of the number inside that order. Okay, order of matrix. So this like is our discussion today for the like starting of matrix. And let's move on to the next topic. I will clear the drawings here. So we can also represent any point x comma y in a plane by a matrix, column or row. So if you have any point on a like in a plane that has the coordinates x comma y, so x comma y can be represented as like x and y in the like your row. Okay, x in the above and y below it, or like x y. For example, point 0 comma 1 can the matrix representation may be given as point p is equal to 0 and 1 only. Okay. So this is the way of representation of your matrix element. Yeah. Let's move further and see what is the next thing. Observe that in this way we can also express the vertices of a closed rectilinear figure in the form of a matrix. So this is the way we can also represent any vertices of a closed rectilinear figure in the form of a matrix. For example, consider a quadrilateral ABCD with vertices A that is 1 comma 0, then B it is 3 comma 2, C is 1 comma 3, and D is minus 1 comma 2. Now quadrilateral ABCD in the matrix form can be represented as, so if you have any quadrilateral ABCD, you can represent it as matrix form also. So matrix X can be represented as the like coordinates of ABCD, and you can like write the coordinates here, X coordinate above and Y coordinate below. So X is here 1, then Y is 0. Similarly for B point, you have 3 the X coordinate, then 2 the Y. For C 1, 3. For D minus 1 and 2. And what is the order of this? 2 cross 4, because here are 2 rows and 4 columns. Okay. Or y is equal to ABCD. The other method is to represent this like this also. Like you can represent ABCD in the rows and your points like in the column wise, okay, or rows wise. Sorry, not column wise, but here rows wise. 1, 0 you have represented in like row only, and the first one you have represented in column wise. Okay, so here the order is 4 cross 2 because there are 4 rows and 2 columns. Thus, matrices can be used as a representation of vertices of a geometrical figures in just a second, in a plane. So that is the method of representing any like figure also in a plane. Now let us consider some examples. We will consider some examples now. I should drop this part. Yes, let's move further. Consider the following information regarding the number of men and women workers in 3 factories 1, 2, and 3. So here is the one condition of like uh, regarding the number of men and women in 3 factories 1, 2, and 3. There are men whose numbers are 30, 25, and 27 in first, second, and third factory, and women workers are like 25, 31, and 26 in these. So represent the above information in the form of a 3 cross 2 matrix. So I have to represent it in a 3 cross 2 matrix. So let's represent it. What does the entry in the third row and second column represent? Okay. So the method of representing the above information in a form of 3 cross 2 matrix is, if you can like write it information as a matrix. I have written it in a form of matrix, that is A matrix, capital A, where 30 and your yes, 30 and 25. Okay. So here 30 and 25 I have written. Here women, then here men. Okay. See here. Okay, men and women. Sorry. So here these are men and these are women. Men and women. For second factory, it is 25, 31. For third, 27, 26. This is the way of representing it in a 3 cross 2 matrix, because there are 3 rows and 2 columns here. The entry in the third row and second column. So which is the entry in the third row and second column? Here was first, second, third. This is the third row. The second column is like this. This is third row and second column is 1, 2. This is the entry in your third row and second column. 3, 2. Okay. So this represents the number of women workers in the factory third. So obviously this is one, this is second factory, this is third factory. So this is first, second, third. So this will represent what? Number of women in your third factory. This is the obvious result here. You can infer from that. Now let's see the example 2 of this. If a matrix has 8 elements, what are the possible orders it can have? Okay. So if the matrix has 8 elements, so you must have the product of the order that will be equal to 8. So that is why we should like see the factors of 8, or then we can find out the respective possible orders for that. Okay. So let's see. We know that if a matrix is order of m plus n, it has mn elements. Thus, to have all possible orders of matrix 8 elements, we will find all ordered pairs of natural numbers whose product is 8. So this is the method. We have to find the pairs of natural number that has the product equal to 8. So all the possible ordered pairs are like 1 cross 8, 8 cross 1, then 4 cross 2, and 2 cross 4. These all are natural numbers, and also the product is equal to 8. There are only these possibilities. You cannot find other possibilities for this. Okay, 1, 8, 4, 2, 2, 4, okay, and 8, 1. So I hope you got this question. Let's move further to the next question. Consider a 3 cross 2 matrix whose elements are given by Aij 1 by 2 mod of I minus Pj. In a general three, so I have to like form a matrix whose elements are in a general form of half into I minus 3j mod. Okay. So in a general 3 cross 2 matrix is given by A, that is it also can be written in the form of like Aij form. So this is Aij form. So you here you have A11 element, then A12, then A21, A22, and A31, A32. This is a representation of your 3 cross 2 matrix only in Ij form. So here Aij element, if I fill the Aij element, its value should be half into mod of I minus 3j, where I goes from 1 to 3. Okay, 1, 2, 3 is the I value, and your j value is what? 1, 2. So this is your I value, like this is your I, this one, and this is your j value, this one. So it goes from j value goes from 1 to 2. Okay. So let's fill the elements for like A11. What is ij value? 1 and 1 only. So the element will be half mod of 1 minus 3 into 1. Okay, what you will get? Half into mod of minus 2 will be equal to 2 only. So 2 by 2, you will get 1. And this is the first element. So A11 I have found out that is equal to 1 only. Okay. Similarly, you can find out A12 like it is equal to 5 by 2. If you like substitute here, you will get the answer. A21 is here half 2 minus 3 into 1, that is equal to 1 by 2. And similarly, A22 is 2, A31 is 0, and A32 is 3 by 2. Just substitute here the values I and j, you will get the result. After taking mod, you will get the positive values for each element. So after getting the values, just substitute it in respective like positions. So you will get the final answer. Okay. This is the like your required matrix, which is 1, 5 by 2, 1 by 2, 2, and your 0 and 3 by 2. Okay. So till now we have discussed many points of your matrix, and also we have seen types of like what are the order and order of matrix and some examples of matrix and representation of matrix, general form of that. Now we will see that what are types of matrices. So yeah, we will see this topic and then we continue the further discussion in the next class. Okay. Yes. So first is the first type matrix is column matrix. The name suggests that a column matrix has only a column matrix, means only a column elements. It has only one column. So this the name also suggests that it has only one element, like one column. Okay, you can see that column is written here. So only one column is there. One column is there. Row can be more. Like here, 1, 2, 3, 4 rows are there, but column must be one. It is called a column matrix. For example, this is a column matrix of order 4 cross 1. This is of order 4 cross 1. In general, A, I, J, M cross 1 is a column matrix of order M cross n. So, if M cross 1, so A is like represented A, I, J, M cross 1. This is the representation of what? Column matrix. Here you can see that it is 1 in the order because it represents what? Second, the second number represents number of columns, and number of columns is here 1. That is why it is represented like this. Okay, now the second type is row matrix. Obviously, the name suggests that it has one row, similar to column matrix. That has one column, so it has one row. Let's move further and see the next type. I will delete the drawings here. Okay, a matrix is said to be a row matrix if it has only one row. For example, this is a row matrix. You can see it has only one row here. Okay, this is one row only here. In general, Bi, like B is a matrix which has the representation of element as Bij, where 1 cross n is a representation of row matrix. Order is 1 cross n. So this is also obvious. Square matrix. What is square matrix? This is very important for you because in this chapter you will deal with like this matrices only, or majorly this matrix. Okay, let's see what is this. A matrix in which the number of rows are equal to the number of columns is said to be a square matrix. So if you have like one row and one column, or two rows and two columns, three rows and three columns, it means that your number of rows and number of columns should be equal. Okay, so that matrix is called what? That is called your square matrix. And the operations, like many operations, like multiplication of matrix, these are like more important for your what? Square matrix only. Many operations can be done on square matrix only, so that is why it is very important. The then m cross n matrix is said to be square matrix if m equal to n, and it is also known as what? Square matrix of order n. Okay, let's move further. So here is an example. A matrix is represented as 3 cross 3. Okay, it has the order of 3 cross 3. See here, you have three rows like this. These are three rows: 1, 2, 3. This and three columns also: 1, 2, 3. So this is the order of 3 cross 3. In general, A, I, J, M cross M is the square matrix of order M. So if you have like written A, I, J, M cross M, this will represent what? Square matrix, because it has order of M. Square matrix of order M, we can represent it like that. Okay. So this was the third type of matrix. The fourth type is diagonal matrix. So as the name says, diagonal is what? If you see here, if you have a square matrix like this, 1, 1, 1, 1, 1, 1, and 1, 1, 1. So you can see here that there is a shape of diagonal also here. Okay, just a second. If you see the elements, they are represented like a square only. Square matrix is this. So here you can see that some diagonal also coming. Diagonal is like this only, like this. Okay, so these are your diagonal elements. Okay, these are your diagonal elements. It starts from one and goes to last element. So these are called diagonal like elements of your matrix. A square matrix Bij M cross M is said to be a diagonal matrix. So this is defined for only square matrix. Like remember this thing. A square matrix is said to be diagonal matrix. So represent this only by a square matrix. You must remember this only. If all its non-diagonal elements are zero, so it's like non-diagonal elements are zero here. So as this is your diagonal only, 1, 2, 3. So these should be filled by some elements. But if other elements of diagonal are zero, this is called a diagonal element, diagonal matrix. Like one, so this element should be 0, 0, 0, 0, 0, 0. Okay, and it is also 0. This one. Yes. So these are 0. Like this. These elements are 0. These are not the diagonal elements, but diagonal elements are filled here. So it is represented by what? Bij is 0, where I not equal to j. It means that these elements where I is equal to j only, these are filled, but where I not equal to j, these are 0. That is why it is written like this. For example, A is equal to 4, B is equal to minus 1, 2, 0, 0, C is equal to minus 1.1, 2, 3, 0, 0, 0, 0 are diagonal matrices of order 1 to 3 respectively. So if you have 1 cross 1 matrix, so this has only one element. So this is representation of diagonal element also, like one element filled here. Similarly, for 2 cross 2 matrix, you have like this are the diagonal elements and the other elements are 0. For C, you have diagonal elements as filled here. For 3 cross 3 matrix, it is like this, and these are 0. So these are examples of like diagonal matrices of order 1 to 3 respectively. Let's move further. So the fifth one is scalar matrix. What is this? So is a if a diagonal matrix is said to be a like it is defined for diagonal matrix only. So if a diagonal matrix is said to be a like it is said to be a scalar matrix if its diagonal elements are equal. That is a square matrix B is equal to Bij M cross or N cross N is said to be a scalar matrix if Bij is equal to 0, but Bij is K and Bij is 0 for what? When I not equal to J. That is the like condition for your diagonal matrix only. So that is applied here. And Bij is equal to K when I is equal to J. So for diagonal elements, you have the values are equal. Elements values are equal. Okay. So for some constant K here. So be constant and its value is constant for like equal to, for each diagonal element. See here. You can see the diagonal elements values are equal here. These are like equal values, diagonal elements. Here also you can see that all the diagonal elements have the equal value root 3. Okay. Next, let's move to the next type. We have seen just now 5 type of matrices. What is the sixth type? Identity matrix. So there are like 7 types given in your uh, NCERT portion. There are other types of also, but you should like only remember these types for your NCERT syllabus and board exams. Also, there are other matrices also. So these are like not in your syllabus, or if they are in syllabus, so they will be asked very little bit. The sixth type of like matrix is identity matrix, a square matrix in which elements in the diagonal are all one. So here all the diagonal elements are like one, and this is also defined for your square matrix only. And rest are all zero is called the identity matrix. So if you have like Aij is one, if I is equal to j, that is for your diagonal element, and is equal to 0 if I is not equal to j. Okay, means that if I is not equal to j, then it will be 0. So it is another type of diagonal matrix. Okay. So we denote the identity matrix of order n by in. So in like is the representation of your identity matrix of order n. When order is clear from the context, we simply write it as I. Okay. So we can also write it like I only if the order is clear here. For example, 1, 1, 1, and 0, 0, and 1, 1, 1, and 0, 0, 0, these are all examples of identity matrices. Okay. So see here, this is a like your 1 cross 1 identity matrix. This is 2 cross 2 identity matrix, and this is 3 cross 3 identity matrix. Okay. So you should remember these also. Now, the last type or 7 type of matrices that is given in your book is zero matrix. So a matrix is said to be a zero matrix or null matrix if all its elements are zero. So what does zero mean? Zero means nothing. So if you have like all the elements zero, for example, like zero array of zero or zero 4 times or zero 6 times or zero 2 times are all zero matrices. There are no entries other than zero only. So these are called your zero matrices. We denote zero matrix by zero only, like O only. Okay, zero not zero but O. So we represent the zero matrix by O. Its order will be clear from the context. So its order will be clear from the context, like context. What is when in the context, it will be clear from that. But till now we have covered today like basics of matrices. What are the like definition of matrices and how the representation of matrices is done and how the elements are represented. Also, we have seen that what are the types of matrices and order of matrix. Okay. So I hope that you liked today's session, and due to some time constraints, we will end the discussion today here. And if you have any kinds of doubts or suggestions, you can comment or ask in the chat box. Also, if you want any one-to-one session or private session from us, you can also contact or tell to us. Okay. So thank you for today's lecture and have a great day.